Thank you very much, everyone, for staying for this talk. I know it's super late in the day. I highly appreciate it. So my name is Gergely Daroczi. I'm from the Spare Course team, and we're working on open source software and free databases, measuring the performance of cloud servers, and also providing tooling so that you can find the optimal instance type for any workloads. So to give you a quick intro, like why this is useful, I've been working as a data scientist for a couple of years, and in some cases we have jobs where we just run a SQL query that's pretty lightweight on the client side. Sometimes we run an R or Python script, which could be super simple, like a linear model, or it can be tricky, like training a hierarchical model, which requires 800 gigs of RAM or multiple GPUs and so on. So to keep it short, I was working with scaling infrastructure for data science with very, very different needs when it comes to compute and running thousands of jobs every day. So to solve for that at the company where I worked previously, and when the idea of Spare Course was born, we built some lightweight Python tooling so that we track every single job that we run every second. So here you can see the CPU usage, also the memory usage. So this is probably some hierarchical model tied to a single core, but requires 180 gigs of RAM. And we have run around 4,000 of these every single day. And we were interested in finding the right instance type for every single job. And obviously there are many, many solutions for this. Like even AWS provides different approaches. There's Kubernetes, but honestly for bad jobs, beam packing is not the right approach. It's great for microservices, applications, and so on, but when you want to run a job with hundreds of gigabytes of memory and GPUs and so on, you put those on the same machine, you end up wasting a lot of money. Like we saved around 65% of the monthly $5,000 AWS cost. So this is a Python script around 1,000 lines, which was managing the infrastructure for us. This was a prototype with logging everything so that we can make educated decisions where to start the next job. And we decided that it can be useful for other things as well, not only for training ML models, but for ETL, traditional CI/CD tools, and so on. So we decided to open source. It's been around for a couple of years, but it was rather limited, AWS only. So we applied for the NGI Search grant. We were fortunate to receive it last year, and Spare Course, which is the next generation of CloudPerf, was born. And to keep it short, we provide database schemas and tools to do the actual ETL job, so data ingest from API vendors and so on, and a bunch of other things. And I have a lot of slides, so I will just go through them. If you are interested, please take a look later on. I will just highlight some features that I think worth noting. So here you can see some stats about what we cover so far. It's 4 vendors. We track more than 2,000 servers. We actually start all those 2,000 server types, run benchmarks on those, do hardware inspection, and make this available for free so that anyone can make use of that data. We track the prices of these servers in over 300 availability zones. So that adds up to like 250,000 price updates every 5 minutes, which include on-demand and spot prices, and we also do the benchmarks. This is a bit outdated. We track over 800,000 benchmark scores on these servers for different purposes, and I will share a little bit more about that later. A quick intro, how you can access our tools. It's available as a website. It's available as a SQL dump of a database. We have SDKs, APIs that you can utilize, but the easiest way is go to sparecourse.com and you have access to all the data. We provide some search tools for the servers. We provide more details once you click on a row. You can find all the prices of a server and the actual benchmarks. So just to highlight a few, top left, it's a memory bandwidth using different block sizes for read and write operations. We use OpenSSL ciphers and some hash functions so that you can see how much operations per request you can expect from a server, let's say a random server from Amazon versus like Azure and so on. We run Geekbench and Passmark and a few other standard benchmarking tools. All that data is available if you are into NLP, text processing, image processing, or something like that. We also provide a front end so that you can easily compare these servers. Here you can see 4 servers. in a simple table including the stats. And I would like to highlight that we are not only tracking what's usually available at the vendor side, like we have 8 virtual CPUs and 16 gigs of RAM, but we are actually looking at, for example, the L1, L2, L3 cache amounts for the CPUs. And later on, I will show that we not only count the number of GPUs and the memory they have, but like the BIOS version and a few other things which might be useful for your needs. This is another view, which is some charts comparing different servers to make it obvious which might be more performant for a given task. And of course, we have some APIs with some docs so that you can get this in a programmatic way, or SDKs. Here you can see the Python one. Unfortunately, I cannot scroll here, but you would find a lot of further data points down there. So as mentioned, SpareCores is an open source ecosystem made up by different components. And I'm sure we will never reach like a lot of stars on GitHub, because who would want to run our ETL tooling on their own? But we do that in public GitHub Actions. If you wish, you can do that. I would rather suggest just use our open and free databases, and you can use the APIs and the web interface and a few other things. So what I wanted to share about our ETL tool, this is making sure that all the APIs from the vendors are integrated, and we get a basic list of servers that are provided at the vendor, and then we will start those and get more data points, as you can see here. Honestly, we thought that it would be super easy, right? You do vendor API integrations, put it into a table, and that's it. It turned out to be much, much more difficult. So even just looking at the database schemas, having problems with all the overlapping compound primary keys, and taking care of all the database migration tools and versioning. And I will just skip that part, but finding data about these servers when you want to get that info from the vendor API is sometimes super difficult. Just to give you an example, I was interested in seeing how much storage a given server has, and I just asked ChatGPT, and you can see that this guy actually managed to find out the number of disks and the storage amount. Doing the multiplication was just too much, so I'm still hopeful that SpareCores has a goal that we can achieve. Just to give you some further info, like why this is difficult, some vendor, I will not name which vendor, but they do not provide any structured info, like how much storage is provided for a given server, like if it has an SSD and how much amount it comes with. So we have to parse it from the server description. So it's like text processing to know if it has an SSD. Or the API doesn't provide info, like any info about the CPU, and the hypervisor is actually hiding that info when running the hardware inspection tool. So we look up the homepage and extract it from there. And bunch of other problems. To give you a simple example, if you have used Amazon AWS previously, EU West 1 is pretty straightforward, that's a region. But the name is actually Europe Ireland, sometimes referred to as EU Ireland, and different API endpoints requires you to use one of these. So we provide a standardized database which provides all these for you in a standard way, so it's much easier to manage the tooling. And we also enrich the data, like we look up if the data center is using only green energy, we have the exact location, if it complies with HIPAA or GDPR, and so on. So another example why this is difficult, at some vendors, the pricing is simple. You want this machine, it costs this amount per hour. Some other vendors are doing this by providing the price of a vCPU and the price of 1 gigabyte of memory. So first you have to figure out how much memory and CPU the machine has. You do the multiplication. Sometimes it's even more difficult because you have to compute the premium pricing on the top of the base price and add these up. Sometimes it's confusing because instance family info is not provided in a structured way. You parse it from the description. Sometimes, like C2 is actually called compute optimized, so it's a huge mess. Good news that we have done the data cleaning. This is run every 5 minutes on GitHub, and you get a database dump with clean data. So this data is provided as a Python package and as a SQLite database that you can download. So far we have run more than 30,000 GitHub actions in public with 900 releases. This database, which only includes metadata on the servers, is growing pretty heavily. So it's over 300 megabyte SQLite file, tracking all the prices I mentioned previously. If you want to integrate this, you just import SC, which stands for spare course data, and the database would be automatically updated in a background thread every 5 or 10 minutes, however you configure this. Another component that we have developed is the inspector, which is run on every single server that we track, and it will do some hardware inspection. Some examples can be seen here. We are adding new features now, like keeping track of all the storages, because you cannot get that from the API, and a bunch of benchmarking workloads. We have added many more since then, like checking the performance of Redis or serving static websites and so on. Again, this is on GitHub. If you're interested, you can check all the outputs. And not only the output, but the actual data that we get from the servers is stored in a Git repo on GitHub. So you can see the raw outputs from all the benchmarks for all the servers that we are tracking. So if you're not interested in our database, but you would like to check the raw output, you can go on GitHub and get that data, or just clone that repo. If you wish to run this on your own machine so that you have a baseline for the comparisons, you can use this Docker image, and on your laptop, server, whatever, once you run it, you will get the same benchmark scores, and you can figure out if you want a similar machine in the cloud or twice the performance, which machines might be the best for your case for the cheapest price in a given region, or based on other filters. There's the runner, which is actually spinning up all the machines at various vendors. We are using Pulumi in the background. That's basically Terraform. It's super useful that we have created some Pulumi templates, and we can use those to start machines with all their dependencies. So some vendors requires you to create a subnet before you can actually spin up a machine. That's automatically handled. And we are also using Pulumi to decommission all the resources that we have created. So once you start a machine, we run all the benchmarks. And then when everything finished, we shut down the machine, terminate it, deleting the storage, network, or whatever other resources have been used. Some fun facts. With vendors, we struggled with capacity and even quotas as well. When you sign up with a new account at, let's say, AWS, as on this example, you get a super small quota. Like you can run 5 machines with 2 vCPUs each. We are running servers with over 1,000 vCPUs and a lot of memories, but to get there, it took around 3 months and a bunch of support tickets so that we get approved, even though we have like $10,000 credit on that vendor. So anyway, they have some quotas, and increasing the quota is difficult. So we ended up with this situation. Just focus on the red line at the bottom. So we just achieved the quota update request quota, which I found pretty hilarious. Anyway, we have the Keeper. This is a public API, or you can host your own if you wish. This is Python with Fast API, SQL model, and a few other open source tools included. A bunch of API endpoints. There's documentation, so you can check that out. And we even integrated some basic LLMs so that if you wish, you can provide an English sentence for what, or English-like sentence for what server you are looking for, and then it will match the API endpoints, filters, and do the searching for you. About the web component, I've shared a few slides before, so I will skip that, but make sure to go to sparecourse.com because we have this fancy slot machine. You enter the amount of vCPUs and memory you need, you click spin, and you will get the cheapest one from many, many different clouds. I will skip the roadmap, but I want to thank the team for working on this. I'm in a good company, as you can see from the profile images, and I want to thank NGI Search and OW2 or OV2 as well for the funding that we received for the previous year. And I get that I'm just used up the 15 minutes, so I will stop here and I will be around if you have any questions. Thank you.
Amazing work you did, perfectly on time.
Thank you.
Thank you very much. Are there any questions? There's one question. It's the last talk, so let's go for a question.
So yeah, I've used Pulumi a couple of times. So if I want to use this spare course, I have to use Pulumi or your API directly, and you provision my infrastructure with Pulumi?
Yeah, we do that in the background for you, so you do not have to actually interact with Pulumi. That's integrated in the SC runner Python package.
And at the moment you are focusing on servers, not like managed services or, I don't know, bandwidth or static IPs or something.
Yeah, that's a great question. We want to focus on compute, but even compute is huge. So we are now focusing on cloud servers, but there's like serverless compute as well, database performance metrics and so on. It will take some time to get there, but we already have some coverage on traffic prices or storage prices, so that's already on the homepage, and you can check for different regions.
That's also not easy sometimes to find out about the egress cost, for example.
So we have that in a standardized way, so we keep track of all the tiers for all the supported vendors and regions, so you just enter the amount of traffic that you are using in a month, and it will list all the available options based on the computed price for that amount. So we take into account all the tiered pricing and so on. Check it out. I think that's pretty cool.
Very cool. Thank you.